All right, let's restart. So I will state some now easy facts, and we will go over the proofs so that you get used to the ideas. Okay, I am trying to do proofs in detail so that you get used to the ideas. How you prove something, how you state something, and so on. One, the first thing, so let me write here some applications of infimum, supremum, and so on. The first one is this. It's a lemma, and it states this. Okay. If for for all epsilon positive, we have A is less than B plus epsilon, then A is less than or equal to B. So what does this tell us? If you add anything to B, any positive number, and you get something larger than A, then B is actually was larger than A to start with. Okay. In other words, if B were not bigger than A, then we could find some epsilon, positive epsilon, so that B plus epsilon wouldn't be larger than A. Evet, bunu şöyle ispat edebiliriz. How we can prove this? We will prove this by proof by contradiction. So assume on the contrary that A is larger than B. I want to show that A is less than or equal to B, and to prove this, we assume the opposite statement, that A is larger than B. So here is the situation. B is somewhere here and A is somewhere here. But our assumption tells us that if I add anything to B, I will get something larger than A. If you look at this picture, you see that that's not true anymore, right? Because if I add something small enough to B, I will not get a real number which is larger than A, right? If I add, something this much, there is no way I get something larger than A. So if I choose my epsilon this much, what is that epsilon? Well, if I choose my epsilon to be the distance between these two divided by 2, then B plus epsilon will be just the halfway between these two real numbers, and B plus epsilon won't be larger than A. So let me just choose this epsilon to be what? A minus B over 2. Okay, then this number, which is B plus epsilon, and B plus epsilon will be less than A, and that's a contradiction to this assumption. So that's the proof. From this picture, I see the proof. However, in mathematics, we have to write things down clearly so that anyone that reads that should be able to understand. So I will keep this picture here, but write my proof here in detail. So we assume that A is larger than B. Then I will choose my epsilon, because you tell me that for any epsilon, B plus epsilon is larger than A. So I have the right to choose the epsilon any way I want. So let epsilon to be this, A minus B over 2. This is a positive number. This is a positive number because şöyle yazayım. Then epsilon is positive because A is larger than B by assumption. But then what is B plus epsilon? Well, B plus epsilon is A minus B over 2. So this is just A plus B over 2. But I know that A is larger than B. Therefore, in this expression, if I replace B by A, I will get something larger, right? So I write A, and instead of this B, I write something bigger, which is A over 2. So I get this. But this means what? So we get B plus epsilon is less than A. But this is a contradiction to the assumption. Right? What was the assumption of the lemma? You see, lemma, the assumption was this. For all positive epsilons, A is less than or equal to B plus epsilon. But I found an epsilon which is positive. But this time B plus epsilon is less than A. This is a contradiction. And why did we arrive at this contradiction? Well, we arrived at this contradiction because we assume that A is greater than B. So this assumption is wrong. Okay, this assumption is wrong because it leaded us to a contradiction. Hence, we must have neydi? Unuttum. We must have A is less than B. Okay. So this finishes the proof. Okay. Another, easy fact is this. If I have two subsets which are bounded from above, then I can add the elements of these subsets. I get another subset from bounded from above. Moreover, the supremum of this new subset will be the sum of the supremums of the two subsets we started with. So let me just state, let A and B be two non-empty subsets of real numbers. Yes. If A and B are bounded from above, then the subset A plus B, I have to tell you what this means, right? A plus B. This is by definition is the following. I just add the elements from A and B. Okay. I just choose arbitrary elements, add them up, and put them into a bag. This new subset is called A plus B. Then this subset is bounded from above. And what? Now I have three subsets which are bounded from above. A, B, and A plus B. So they have all supremums. And the statement about supremums is this. Then supremum of A plus B is just supremum of A. I should write this here. Supremum of A plus B is supremum of A plus supremum of B. Okay. So there are basically two things to be proved. First of all, we need to show that A plus B is bounded from above. And the second thing we need to prove that supremum of this new subset is equal to the sum of the supremums of the previous two subsets. Well, let's see how we can prove this. Sorry. First, let's start with the boundedness of A plus B. All right, that's easy. You see, A and B are bounded from above. Since A and B are both bounded from above, supremums exist. Sub A and sub B exists, and they are upper bounds, and they are upper bounds for A and B respectively, right? Sorry. In other words, if A is in A, then A is less than or equal to supremum of A, and if B is in B, then B is less than or equal to supremum of B. Well, if I add these two inequalities side by side, then we get what? Then A plus B is a typical element of the subset A plus B, and this is less than supremum of A plus supremum of B. So what we see is that A plus B is less than this number, but A and B are just arbitrary elements from A and B, and this is a typical element of the subset A plus B. So any element of the subset A plus B is less than this real number. Therefore, this real number is an upper bound for the subset A plus B. Hence, sub A plus sub B is an upper bound for A plus B, right? Well, this means that the subset A plus B, first of all, is bounded from above, and not only that, but we also know that it has a supremum, because any subset which is bounded from above is has a supremum. Okay. Thus, a plus b is bounded from above, and supremum of a plus b exists. Right? Any bounded subset from above has a supremum. All right. Well, this supremum exists, and we also know that, you know, this real number sub a plus sub b is an upper bound. However, supremum is the least upper bound. Therefore, this real number must be smaller than or equal to supremum a plus supremum b. In particular, supremum of a plus b must be less than or equal to supremum a plus supremum b. Why is that? Let me say it one more time. Sub a plus sub b is an upper bound. However, this is the least upper bound. Therefore, any upper bound of a plus b is greater than or equal to the supremum of a plus b. Okay, my aim was to prove that these two real numbers are equal. We got, half of the proof that this is less than or equal to this number. Now I will try to get the inequality the other way around, so that this supremum is greater than or equal to this real number. Therefore, they have to be equal. Okay. And this is how we will proceed. I will use the previous lemma, actually. Okay. So let epsilon be any positive real number. Okay. I will show that any real number, a positive real number. I will show that sub a plus b plus epsilon is larger than or equal to sub a plus sub b. So whenever I add something like this, a positive number to this one, I'll show that we get something strictly larger than this number. Not strictly larger, but something greater than or equal to this number. So by the above lemma, if I can prove this, you will see that I can just raise this epsilon and get that supremum of a plus b is larger than supremum a plus supremum b. Okay, let's see how we can prove this. Well, epsilon is positive. Half of it is also positive. Since epsilon is positive, epsilon over 2 is positive. Okay. And in this case, hence, supremum a minus epsilon over 2 is not an upper bound for a. Well, this is not an upper bound for a means what? There is some element in a which is larger than this element. So there is some a in a with a is larger than, right, supremum of A minus epsilon over 2. Değil mi? Yani supremum A eksi epsilon bölü 2. A için bir üst sınır olmadığına göre A'nın içinde bir eleman var. Öyle ki o eleman bundan büyük. Aynı şey B için de geçerli. Similarly, supremum of B minus epsilon over 2 is not an upper bound for B, and thus there is some B in B with B larger than or equal to, larger than supremum of B minus epsilon over 2. Okay. Well, let's take these two inequalities. This one and this one, and add them up. So we get what? A plus B is larger than supremum of A plus supremum of B minus epsilon over 2 plus epsilon over 2, which is epsilon. So we get we get this. Okay. So, but I know this. This is an element of A plus B, right? Şöyle diyeyim. Moreover, A plus B, because A is from A, B is from B, so this is an element of A plus B, and thus supremum of A plus B is larger than A plus B, right? Because it's the supremum. So we get the following: supremum of A plus B, which is larger than A plus, larger than or equal to this, and this is larger than supremum of A plus supremum of B minus epsilon. So we get what? Supremum of A plus B plus epsilon is larger than supremum of A plus supremum of B. Well, actually, I got something a little bit stronger than I wanted to prove, right? I got strict inequality, but if this is true, then of course I have this. Right? If this is larger than this, then it is larger or equal to this. And this is what we wanted to prove, right? I told you that I will show that this is larger than this thing. Well, it is. Sorry. So I obtained, well, what is the passage? No. I have epsilon here. Supremum of A plus supremum of B. But this is true for all epsilon, right? So I will finish this as follows. Since epsilon positive was arbitrary, we deduce by the previous lemma that what? Ne görüyoruz burada? For any positive real number epsilon, this real number plus epsilon is larger than this one or equal to this one. Well, the previous lemma tells us that in this case, this number is larger than or equal to this number to start with. Okay. By the previous lemma, we see that supremum of a plus b is larger than supremum a plus supremum b. So I obtained this inequality. This is the inequality I wanted to obtain because you see I had, where was it? I had this one, right? I had this inequality. I had this, and now I have this. If you combine these two, hence we obtain supremum of a plus b is equal to supremum of a plus supremum of b. Okay, and this finishes the proof. Okay. Hiç save etmediğimi düşündüm. Fark ettim de bu yazdıklarım, o yüzden onu save ettim. Okay, what else? There's also a little proposition which says this. Let me also do that. Okay, so let A and B be two subsets of R such that for every A in A there is some B in B with A is less than or equal to B. Okay, the conclusion is this. If B is bounded from above, then A is bounded. A is also bounded from above, and supremum of A is less than supremum of B. Okay. So again, this proposition has two parts. If A and B are two subsets such that for every element of A of A, there is an element B of B which is larger than that element. And if B is bounded, then A is bounded and the supremum of A cannot be larger than the supremum of B. Yani bu bir yerde şunu söylüyor. Elinizdeki küme varsa A'daki her elemandan daha büyük bir eleman B'de bulunuyorsa o zaman B'nin supremumu A'nın supremumundan büyüktür. Değil mi? This fact sounds obvious, right? But it needs a proof. Let's see why this is true. So I have to prove again two things. That A is bounded from above and supremum is less than this. So this is how we will proceed. Let A in A. Then by the assumption there is some B in B with A is less than or equal to B. This is the assumption. But we know that B is bounded from above. Since B is bounded from above, supremum of B exists, and this number, whatever it is less than supremum of B, because supremum of B is an upper bound. Hence, we get this: A is less than B, and it is less than supremum of B. And this is true for any A, because I had this A, I got something here, but this supremum is independent of this. Therefore, supremum of B is larger than any element of A. So that supremum of B is an upper bound. For A. So this means what? This set A has an upper bound. Therefore, A is bounded from above, and therefore it is a supremum, and that supremum is, of course, is less than or equal to any upper bound. In particular, it is less than or equal to supremum B. Finally, we deduce that A is bounded from above by supremum B, and thus supremum A exists and satisfies this. Because, supremum of a set is less than or equal to any upper bound, and this is an upper bound for A. Therefore, it must be greater than or equal to supremum of A. Okay. Well, of course, one can state and prove dual facts. I won't do the proof of this, but let's let me leave it as an exercise. Or exercises, let me say. First one is this. If A and B are non-empty subsets, subsets which are bounded from this time below, then their infimums exist, right? Bounded from below. Then A plus B, what is this set? I take elements from A and elements from B and add them up, right? Those elements form the subset A plus B. Then this subset is bounded from below and that supremum, not supremum, I'm sorry. Since it is bounded from below, it has infimum. Infimum of A plus B is equal to infimum of A plus infimum of B. Okay. So I want you to, work on the proof of this. And the other dual fact is this: if A and B are subsets of R, so that for any A in A there is some B in B with B is less than A. Okay. Yani A'nın her elemanından daha küçük bir elemana sahip B. Siz hangi elemanı verirseniz B'de ondan daha küçüğü var. Okay. Then the conclusion is this. Then if B is bounded from below, then A is bounded from below, and I can compare the infimums. Infimum of B is less than or equal to infimum of A, because B has smaller elements, right? In this sense, whenever you give me something from A, I can find something from B which is less than that element. This doesn't mean that all the elements of B are less than all the elements of A, but it means the following: any A in A, for any A in A, there is some B which is less than that element. And that implies that infimum B is less than infimum A. I will leave the proofs of these two as an exercise to you. So your exercise: prove these statements. The proofs will be completely analogous to the proofs I have given, but you may choose some other ways. Okay. You don't have to do it the way I did I did prove the previous facts. You can find some other proofs. As long as they are correct, it doesn't matter how you prove it. Okay. For today, let me stop the recording.